Hello guys, welcome to this lesson. So in this lesson, we want to look at vector projection. In the previous lesson, we looked at scalar projection. So remember that this formula for computing scalar projection is modulus of C equal to A dot B all over absolute value of A. This is called projection of A onto B, okay? And B onto A is given as B dot A all over modulus of A. So this is what we learned in the previous lesson. So now when we talk about vector projection, we're still talking about the same thing, the same process, but now our answer is going to be a vector. So if we have this diagram, let's say we have this diagram for instance, and this place is right angle, so this is vector A, this is angle theta in this direction, so this is vector projection is going to be given in this direction here. It's called the vector projection. Vector projection, okay. So this is the direction we have, and this is what we have. Now, how can we compute vector projection? If we give this place as C as usual, with what we have before, you know that cos theta equals to magnitude of C over A, okay, and that was what we used before, and this magnitude of C was set to be equal to scalar projection, right? Scalar projection. So now, if we are to compute this C normally, so in each in the diagram, vector C is the vector projection now. Okay, vector C is now a vector projection. So let's C equals to vector projection Then C, what will be C? C is going to be magnitude of B. C equals to absolute value of C multiplied by magnitude of B all over absolute value of B. So this is how to compute that. This is how to compute it. And of course, we know that magnitude of C is equals to A dot B all over magnitude of B, right? So if we substitute into this formula, we're going to have that C equals to magnitude of C multiplied by B all over magnitude of B, which is A dot B all over magnitude of B dot B, okay, multiplied by B all over magnitude of B, okay. And what are we going to have here if we do that? Simply, so this is going to be A dot B, okay, all over B dot B multiplied by vector B, okay. So this formula is called scalar projection. Vector projection rather. Vector projection is a vector. So this is called vector projection. Vector projection of A onto B. Okay, so this is what we have. A dot B all over B dot B. The reason why it is so is because magnitude of B times magnitude of B is equals to B dot B. Okay, e.g. if we compute, let B equals to 2I plus 4J and the same B. So let's do B dot B. B dot B is 2 square plus 4 square, which is what? So 2 square is 4, 4 square is 16, so that's going to be 20. So do magnitude of B times magnitude of B. Magnitude of B will be equals to square root of 20, okay? So magnitude of B times magnitude of B. Magnitude of B times magnitude of B, that will be root 20 times root 20. So that's root 20 times root 20, which is equal to 20. So you can see that they are equal. So that's just that. And then again, so we can find projection. So projection, vector projection, vector projection of B onto A. B onto A is given as B dot A all over A dot A multiplied by A. Okay, that's as we have A dot B over B dot B multiplied by. So this is what we have there. So this is how you can change the formula. Okay. So this is how you can change the formula and solve examples. So let's see examples here. Examples. So consider okay, let's say example 1 instead of that. Example 1. Look at this vector. A is 2i minus 5j. B is minus 2i plus 3j. So we are A. Find vector projection of A onto B. And B. Find vector projection of B onto A. Okay, so let's solve these problems all together. So we have that solution. So vector A is equals to 2 minus 5. Vector B is equal to minus 2, 3. So A, vector projection of A onto B, that will be equal to A dot B all over B dot B multiplied by B. Okay, so and then we have to compute A dot B, so that will be 2 minus 5 dot minus 2, 3, and that will be 2 times minus 2 plus minus 5 times 3. So that will be equals to minus 4 minus 15, which is minus 19. And B dot B will be equal to minus 2 or minus 2, 3, minus 2, 3. Okay, so that will be minus 2 squared plus 3 squared. So which is 4 plus 9, which is 13. Okay, so therefore A dot B all over B dot B multiplied by B will be equal to, that we're going to have in that place, will be equal to, so A dot B was minus 19, so that will be minus 19 minus 19 all over 13 multiplied by vector B minus 2, 3. Okay, and that is going to further be equal to, so therefore, so that is always magnitude of C, so therefore magnitude of C equal to minus 19 all over 13 multiplied by minus 2i plus 3j. Okay, which we can that's very well as that. So that is the answer. That is the answer. So that is the answer. So B, we have to find projection of B onto A. So that is going to be magnitude of C equal to B dot A all over A dot A multiplied by A. So B dot A is also the same thing as what we had before, right? It's the same thing, so but let's just complete it. 2 minus 5. So this is going to be minus 2 times 2 plus 3 times minus 5, and that is going to be minus 4 minus 15, which is still minus 19. So A dot A will be equals to 2 minus 5 dot 2 minus 5, which is 4 plus minus 5 squared, that is 4 plus 25, which is 29. Okay, so now our projection, load C, which is equals to B dot A all over A dot A multiplied by A, okay, will be equal to B dot A, which is still 13, same thing that we have. Okay, B dot A minus 19, so that will be minus 19 over 29 multiplied by factor A, which is 2 comma minus 5. So the answer will be minus 19 over 29 multiplied by 2I minus 5J. So this is how to compute a projection of the other form. So find the vector projection of a perpendicular to B. So we have another question there.